We're going to continue to look at factors that influence Earth's climate and ultimately influence the distribution of life. One of those factors is planetary. We refer to them as the global ocean currents. Prevailing winds blow over the ocean to produce mass movements of surface water. These winds are influenced by Earth's rotation, and therefore the currents are influenced by Earth's rotation. Ocean currents that originate along the equator help to redistribute that heat to the poles. In this way, our ocean currents are like a giant heat pump that help to moderate Earth's climate. Not only do these currents move at the surface, but they also move vertically. In fact, density plays a critical role in that vertical distribution and self-perpetuating heat pump that keeps these ocean currents moving like a conveyor belt. Density is controlled by what we call thermohaline circulation. Thermo as in temperature, warm water is less dense, rises. Cold water, more dense, sinks. Salty water is more dense, fresh water is less dense. These differences in density help to perpetuate this loop in this conveyor belt, keeping the ocean currents moving. You can see that they not only move at the surface, but they also have depth as ocean water moves from the depths to the surface and from the surface to the depths below. Here's a map of the Earth's global ocean currents. You notice that there are red currents that originate at the equator to help redistribute that heat towards our polar areas. And we have blue arrows that represent our cold currents originating from the poles, delivering cold water towards the equator. I want to focus on the Gulf Stream. This is one of our more famous ocean currents. Notice the Gulf Stream originates along the equator. It is considered a warm current that helps to moderate coastal climates. This is a very famous one, as the Gulf Stream, as you can see, passes right through the Gulf of Mexico, along the eastern seaboard of the United States, and past the United Kingdom. What happens is, as it passes the United Kingdom, a lot of that warm water evaporates and seeds the clouds. With the evaporation of water, the current becomes more salty because the salt doesn't go anywhere. Furthermore, this current gets colder as it moves towards the poles. So the water becomes more dense and it sinks in mass, and it sets up this self-perpetuating conveyor belt that keeps this heat pump going. It's absolutely critical to many countries in Western Europe, including England. Adding moisture to the atmosphere raises the specific heat. That keeps their summers somewhat cool, but it also keeps their winters somewhat warm. That has a really important moderating effect on their climate. As you'll notice, much of England shares a similar latitude as Alaska, but of course England does not have an Alaskan climate. It is affected by this heat pump. There are many climatologists concerned that this heat pump may stop one day because of climate change. This has happened in the past. During our last glaciation, there were several massive ice dams that built up in the Great Lakes. Behind the ice dams were huge pools, massive lakes of cold, fresh water. One dam broke one day and it collapsed, releasing all of that cold, fresh water, and it ripped out through the St. Lawrence and it diluted the Gulf Stream. That cold water prevented the Gulf Stream from sinking because it was fresh. It wasn't salty anymore. It turned that heat pump off and it plunged much of Western Europe into an ice age. Now this same phenomenon may occur, and we're concerned. We don't have glaciers here in North America, but we certainly have massive continental glaciers in Greenland. As climate change occurs, these massive sheets of ice are melting, delivering cold, fresh water into the ocean, which are diluting these salty Gulf Stream currents. That could prevent them from sinking, and ultimately that could shut down this heat pump, plunging Western Europe into another ice age. You guys are going to watch a short little animated video that will show you exactly how that will work.